replication in sites. I don't know if you've ever had a rumor go around about you. I remember when I went to college, I went to a really small college in Kansas City, and unlike a lot of colleges where, Yale and Harvard, I guess, they'll have rich kids show up driving Porsches and Ferraris and stuff like that. Well, I showed up at my college driving a 1972 Ford Pinto Death Trap. You might remember that the Ford Pinto was the one that gets rear-ended and blows up in flames. Well, we were all poor at my college, but one Christmas break I went home and my dad bought me a new set of tires, and when I came back with a new set of tires on, someone else mentioned to me, they said, "Hey, you got some new tires there, huh?" And I said, "Yeah, my dad bought them for me." Well, apparently that somehow launched a rumor that my parents were wealthy. And I have to admit, I kind of enjoyed it for a little while because finally the girls started paying attention to me and all this kind of stuff, but I eventually had to squash that rumor. And that's one of the two rumors that's been told about me. The other rumor I can't really comment on. What can I say? I was young and I needed the money. Anyway, Active Directory also spreads rumors, except that Active Directory is different than people, because Active Directory wants to tell the same story from one domain controller to the next and not exaggerate or blow things out of proportion or leave anything out. What we want is convergence among all of our domain controllers so we have consistency with the directory database. And that's what we're going to be talking about in this nugget, and that is replication. And that's how data gets from one domain controller to the next. And we'll start off with a little bit of the basics of Active Directory, some of the things that make it work well, some of the things that make it work the way it does, a little bit of background on it. We'll also start talking about some of the services that are involved, such as the Knowledge Consistency Checker, or KCC, and the Intersite Topology Generator, or the ISTG. And it's these services that make sure that there's a way to get from one domain controller to the next and transport the data across to those domain controllers. Let's take a look at the timing of Active Directory replication. How long does it take in one site to get from one domain controller to the next within that site? We'll see that it's quite a lot faster than what we had in Windows 2000, and it's still pretty efficient as well. And then we'll take a look at sites, which is going to be an area of high-speed connectivity, and it'll often mirror your cities where your company is located. Like your Phoenix site, your Los Angeles site, your New York site, and so forth. We'll just kind of introduce sites in this nugget, and then in the next nugget we'll get into more detail about sites and how to configure them. Well, when it comes to replication, Microsoft has built several things into Active Directory that help to make it more efficient. The first thing is just management of the bandwidth. For example, only individual attributes are going to be replicated if there's been a change to an individual attribute. For example, if I've got a user account and that user account has changed their phone number. Well, we're just going to change that phone number in Active Directory users and computers, but the next time a replication cycle takes place, we only want that one phone number to replicate to the other domain controllers. And with Active Directory, we can do that instead of replicating the entire user object. Moreover, we can just replicate information out of a specific naming context. For example, let's go back to that user object. Well, that's part of the domain naming context for the domain. So if we have something in the domain naming context that needs to get replicated, that's all we're going to replicate. We don't have to replicate all the naming context with every replication cycle. I mean, some organizations have Active Directory databases that approach a gigabyte in size. And if you have to replicate that whole thing every single time there's one little change to Active Directory, it's going to choke your network and you really can't work with it. So that's why Microsoft makes it so much more efficient. Plus, you can configure sites as an administrator, and this is something that you will manually do. There's going to be one site already there, but you can add additional sites, and then you can use different replication mechanisms to control the bandwidth and control when replication takes place from one site to the next. We'll talk quite a lot about sites again here in a little while. And then, of course, the other thing that's really important in all of this is to make sure that we have good integrity in the data. I mean, there are certain things that could happen apart from various measures that are taking place that could potentially corrupt the data or have the data be out of date and never get up to date. So we have to keep in mind some of those things. One of the things that Microsoft does place for us, though, is loose coupling. And although that sounds like some kind of a term from Woodstock or something, what this really means is that it's possible for the data to be different on two different domain controllers, and that be acceptable for a limited period of time. And that's because we don't really want data to be updated immediately throughout the entire enterprise. I mean, it sounds like a good idea, but you really don't. I mean, for example, if I create a new security group on one domain controller, and I've got 200 domain controllers globally, do I want it to replicate that group out in the very instant that I've clicked on OK and created that security group? I don't think so. Because we want to keep more judicious use of our network bandwidth than that. So, for a period of time that's acceptable, we have what we call loose coupling so that it's permissible for two different domain controllers, two or more, to have different data for a while. The other thing relating to collision control is something called loose time stamping. And this means that if we have two domain controllers that have updates to a particular property, then there has to be a means for resolving those two updates, because when they collide or when they replicate with one another, they're both going to realize, oh, wait a minute, you've got an update, but so do I, so which one's right? Well, the domain controllers don't really determine which one's right, but they have to have some measure of collision control to make sure that the conflicting settings in a particular attribute don't cause corruption in the database. And one of the ways of doing that is through loose time stamping. Because with some kinds of databases, it's only the last writer in terms of the timestamp that wins. However, in terms of replication and Active Directory replication, there's a lot more things that take place in that, and you can use a timestamp, but that's usually the last effort or the last resort in terms of resolving a collision. And instead, we're going to be using something called version numbers, and there's different places where these will appear, such as property version numbers, up-to-dateness vectors, update sequence numbers, and all these kinds of things, which is numbering schemes that are used to identify when an update was made and what domain controller it was made on. And then one of the things that those kinds of things will help prevent is so that we have a domain controller that requests an update from another domain controller. It doesn't want to request data that it has already received. And all of those version numbers will help to prevent that from happening. It's called propagation dampening. Well, what is it that makes Active Directory happen? How does it know what domain controllers to replicate with, and how does it know the most efficient topology to create? Well, that's because of a few services that are in place with Windows Server 2003. The first of those is the Knowledge Consistency Checker, or the KCC. What this is going to do is going to determine what the most efficient replication topology is. And what it does is it will determine the connection that needs to be made between two domain controllers, and it builds a connection object between those two domain controllers. And this is simply a definition of the replication path between those domain controllers. And then as you add domain controllers, it may get into a more elaborate replication topology, but the KCC within a single site always limits itself to a 3-hop limit. And if it needs to, it'll stay within a ring topology and a 3-hop limit. But if you add so many servers in there, so many domain controllers, that it can't keep that 3-hop limit in a ring, then what it does is it converts over to a mesh topology. Let's take a look at that. See, here we've got 6 domain controllers, and you'll notice that no matter which way I go, I can always get to the furthermost domain controller within 3 hops. So let's say that here I've created a new user account on this domain controller. Well, we need to eventually get that down to this domain controller. How's it going to do that? Well, it has to do that within 3 hops in order to keep these kind of connection objects, and that's just what's represented by these double arrows here. Because replication is bidirectional. It can replicate to this domain controller, or it can replicate from this domain controller. Anyway, we got the new user account. Here's 1 hop, 2 hops, 3 hops to the furthermost domain controller. Therefore, we can keep and maintain a ring topology. Now, this is what would happen if we had more domain controllers than was possible to reach the furthermost domain controller within 3 hops. So again, here, if I have my little user account that I create, oh, hey, that's about the neatest stick person I've ever drawn. I'm quite proud of myself. Anyway, so if we want to get this new user object down to this domain controller, what would we normally do in a ring topology? We'd have 1, 2, 3, oops, there's 4 hops. Well, 4 hops aren't allowed by the KCC. So what it's going to have to do is to build in these optimizing connections, and that's what these are called. It builds in additional connection objects to make sure that we can get to the furthermost domain controller within 3 hops. That means that in this case, we'd have 1, 2, 3 hops. We're still within our 3-hop limit. It just had to start building a mesh topology with these optimizing connections here in the middle. Now let's take a look at when these Active Directory changes get propagated to other domain controllers throughout the environment. Let me recreate my user account here. So I've got a user account here, a new change on this originating domain controller. Well, first of all, let's compare it to Windows 2000, because many of you might be coming from Windows 2000 environment, and it is different than it was in Windows 2000. In Windows 2000, what would happen is, after this change is made on the originating domain controller, it will wait 5 minutes, and then it will send an update notification down to this domain controller, which then pulls down any new Active Directory data from this domain controller. And then in Windows 2000, if it has any other domain controllers to which it needs to send updates, like this one over here, which is also a ring neighbor, then it would do the 5-minute thing as here, but it would also stagger it or pad it with an additional 30 seconds before it would send that update notification over to this domain controller. And that's so that this domain controller is not sending out simultaneous updates to a number of different domain controllers and potentially overwhelming that domain controller. Well, that's not the way it works in Windows Server 2003. In Windows Server 2003, rather than wait 5 minutes, it's much, much shorter now. It'll only wait 15 seconds. So we got a very fast convergence time in Windows Server 2003. So it sends down its update notification here. This will pull the data as it did in Windows 2000. Here, it will also do the 15-second thing, but it will pad it by 3 seconds here. So now we got a total of 18 seconds before this domain controller will pull the data. And again, that's so we don't have simultaneous and overwhelming replication data coming out of this domain controller. And then for the rest of this, yes, this domain controller has now received its update. Then it will do the same thing that this domain controller did. It'll wait 15 seconds, send the update notification down to this domain controller, which will then pull it. This one will do a similar function over here. It'll wait 15 seconds. And then pretty soon, before very long, we've pretty much got the same data all the way around our network in our intra-site replication. Now, all these domain controllers will have the same data replicated to them, and they all come to a point of convergence, meaning that they all agree on Active Directory at that point. And that'll take place in about 45 seconds, because we have 3 hops to the furthermost domain controller. That's 15 times 3, 45 seconds. A lot better than what we had in Windows 2000, when we'd have 3 hops times 5 minutes, so it'd be about 15 minutes before we would have convergence in intra-site replication in Windows 2000. Now, all of this so far here only relates to intra-site replication, the KCC and all of these things right here. We'll also have to consider, however, replication between sites. And for that, you don't want to use the same calculations that the KCC uses for a single site. That's why you're going to build sites. And we'll see that a little while later on. In order to build those sites and to determine the frequency of the replication between those sites, however, there's a directory replication agent, or a DRA, that determines how frequently the replication takes place, and it uses the schedules in the site link and connection objects to determine how often to perform that replication. And then there's another service called the Inter-Site Topology Generator. And what that does is it determines the most efficient path between sites. This is a special role that's taken on by what we call bridgehead servers. The bridgehead servers are the connection points between sites that actually send and receive replication data between the sites. And those bridgehead servers will have the Inter-Site Topology Generator on them, which is a calculation that will determine what the best path is between multiple sites to get data from one location to the next. This has also been improved in Windows Server 2003, because in Windows 2000, you were limited to about 100 sites before it got to be too many calculations on the bridgehead server, and it kind of choked down the processor utilization on that bridgehead server. Well, now it's a much simpler mechanism, a much simpler algorithm, but still very good, and it works very well, so you don't have that limitation with 100 sites anymore. Well, throughout this series, I've kind of mentioned what a site is just on the periphery of other issues, but now let's get a little bit more specific about what a site really is. And first of all, notice that a site is going to typically mirror your physical topology. So you'll often see a site follow something like your cities or something like that. Let's go ahead and take a look. For example, here I've got the nuggetlab.com domain, and it's located in a site called Phoenix. This is going to be a concentration of my user community, and it's also going to be an area of high-speed network connectivity. Typically, it's probably going to be a 10 megabit or 100 megabit per second LAN that we have there. And then that's going to be separated from my other sites by a link of some kind, and a WAN link, in this case, a T1 line. And that T1 line will then distinguish my other user community where I have high-speed network access in Tucson here, where I, again, probably have a 10 or 100 megabit per second network. And then finally, we'll see that the Tucson site is further separated from my Benson site, which is another city in Arizona, a small town in Arizona, South Arizona, where I have another user community of high-speed interconnections here as well. And by the way, what does Microsoft consider high speed? I mentioned 10 megabits per second. I mentioned 100 megabits per second. Microsoft actually considers a high-speed network to be anything that's either 500 or 512 kilobits per second or higher. I say 500 or 512 because they have different documentation that some says 500, some says 512. Anyway, they also say that it's best if you're going to have a high-speed network, quote-unquote, you need to have 128 megabits of available network bandwidth. That means any network bandwidth that's left after your ordinary network traffic. So in this case, if any of these links are not heavily overly utilized, and I've got at least 128 megabits per second left, what would the harm be in making this whole thing just one giant site? Because this is 512 or faster. This is faster than 512 because that would be, let's see, T1 is 1.544 megabits per second. So why couldn't I just make this whole thing one gigantic site? In fact, I consulted for a telecommunications company once where they were asking me that when they were doing their Windows 2000 rollout. Because for them, they had a whole bunch of sites around the United States and the world, but these were all connected by OC3 lines. Well, an OC3 line, that's an optical line that's faster than your LAN connections usually. So why couldn't they take all these major cities that were hundreds of miles apart and just make them all one big site? Well, there's a couple of reasons for that. Number one, you want to localize your access as much as possible, because even if you've got an OC3 connection or a T1 connection or something like that, you want to localize your access to various resources. Number one, for example, is if you use the distributed file system, or DFS. You see, sites know which subnets are in a given location. And if I make them all in just one gigantic site, I'm going to have a DFS file share down here that a user up here is accessing, and they're having to go through this link and then out to this link to retrieve a DFS file share. And DFS is just a distributing file system which allows us to keep redundant copies of files in a number of different locations. And typically it's going to be read-only data, but it doesn't have to be. So that would be one thing we'd want to localize. How about some other things? Well, domain controllers. I mean, I could have a single area of high-speed connectivity again here if I want, but that means that I have a user logging onto a computer here that's going to have to hop through Tucson over here to Benson to log on to a domain controller down here and have all of the Kerberos transactions, ticket exchanges, all that kind of stuff take place really ultimately over a 512K line. And if I get too many of that action going on here, I'm going to get substantially below my available bandwidth here. Other resources we might want to keep local would be things such as printers, because with a printer you can do something called location tracking, where it will identify what subnet a printer is on. Active Directory can identify that. And then if I have a user that maybe, for example, travels from Tucson up here to Phoenix, they're trying to look for a printer, well, on the basis of what subnet they're on that they've been distributed, what they've been given by a DHCP server, then Active Directory can associate them with or locate for them a printer on their same subnet, instead of them just blindly going through Active Directory and searching for printers and happen to find one down here in Benson, trying to print a large document over a 512K line over here to Benson then. So those are just a few of the things we want to isolate, things such as DFS, printers, and most typically domain controllers and logon access. Now also, your sites are typically grouped according to your user community, as I mentioned earlier, and that only makes sense because if you look at your diagram, typically you're going to have users that live in Phoenix, driving to Phoenix, some office in Phoenix, and logging on. So it's a cluster of our user community there. Other things that we'll have in relation to our sites is that we want to make them areas of reliable, high-speed network access. Typically, something like a LAN is going to be considered an area of reliable high-speed access. Now, even though here I qualify for high speed with 512 kilobits per second between these two sites, I might still not want to put them in just one site. I might want to still make them separately Benson and Tucson here, because this might be an unreliable WAN link. It might go down often. And if that's the case, then I have all my domain controllers in the physical Tucson location. Then the Benson people here are cut off from the domain, cut off from various resources. They can't log on. They may not have a global catalog server, even if they do have a domain controller down here. So you can see again where it would not make sense to make these two things one site. A site is also domain independent. I mean, you don't have to have one site per domain. I mean, I could have, in addition to nuggetlab.com in the same site up here, I could also have cbtnuggets.com. I could have, a dozen sites or a dozen domains up here in the same site. Likewise, the domain is not limited to a single site. We have nuggetlab.com here and nuggetlab.com here and here. So we don't have to be limited, and a site is domain independent in that sense. Except that you do have to have at least one domain in a site. And as I was mentioning earlier, we also want to localize our access, as in with our domain controller logons. We want to log on to a local domain controller in whatever site applies. We also want to control our WAN traffic. That's another thing that we get with site. You see here, especially over this 512K connection, I want to conserve that bandwidth. And if I don't have a lot of Active Directory data that needs to be up to date, real snappy, right on the moment down here, I might configure this only to replicate a couple of times a day and conserve my bandwidth over this slow connection. Because generally, especially with a slower link like this one, we as network administrators have a tendency to want to be stingy with that network traffic, and that's a good thing. In this nugget, we took a look at replication and the basics and the background of replication. We took a look at, for example, some of the way that the management of the bandwidth helps to make sure that you get up-to-date information on your domain controllers without swamping the network with constant replication traffic. And that's really done by making sure that there's an interval in which there's a delay before replicating traffic to other domain controllers. And we looked at several of the services as well, such as the KCC, the ISTG, the DRA, all of those things that are necessary in order to build connection objects and to time the replication from one domain controller to the next. We also did look at that specific timing, especially in TrustSite, and we saw that it's quite a lot faster than Windows 2000. Well, we're looking at about a total of 15 minutes convergence time in TrustSite because you got 5 minutes between hops. Well, now with Windows Server 2003 with 15 seconds between hops, we're looking at about 45 seconds for total convergence within a site. And then we also did look at sites, and we'll discuss that in more depth in our next nugget. I hope this has been informative for you, and I'd like to thank you for viewing.